0.47 and tau c is 0.56. Okay, so here our tau VE, this value we got 2.47 MPa, Newton per mm square, and tau c value we have calculated the permissible shear stress, and that value is 0.56 Newton per mm square. Okay, that is MP. So now we have got the value of tau c and tau v. Now what is our next step? Our next step is here, if we see your tau VE value is greater than tau C. Okay, your tau VE value, it is greater than tau C. So what does it implies? It states that, so therefore shear reinforcement is required. Okay, shear reinforcement is required. Okay, so here the shear reinforcement is required. Now for that purpose, now what we need to do, we will decide the two-legged 10 mm diameter stirrups, and then we will find out the spacing of the stirrup. Okay, so here now providing two-leg two-leg 10 mm diameter stirrups. Two-legged 10 mm diameter stirrups. Okay, now calculate the area of stirrups. ASB is equal to, so the area of stirrups will be 2 into pi by 4 into 10 square. So what is the answer? Let me know the answer. What is the answer for ASB? One 157.07. Okay, so this value is 157.07 mm. Now going to the pair, we should go to the IS code, page number 75. So on that page, formula is given. Okay, so if we go to the IS code now, so here in the IS code, this formula we can use now to calculate the what we can say, spacing of the stirrups. So this is the formula. Now we are going to use this formula to calculate the spacing, but before using this formula, here terms are there B1, D1. Okay, so we need to find out the value of B1 and D1 first. After that we can use this formula. Okay, this is from clause number 41.4.3. Okay, transverse reinforcement clause. So for that B1 D1 is required. Now first of all we will calculate this B1 and D1, and afterwards we will use this formula to calculate the spacing. So now we will go to our board. Okay, so now here next thing is to calculate the B1 and D1. Okay, so to calculate B1 and D1 now, suppose this is the stirrup. Okay, this is the stirrup. Then here this is the beam. This is the cross section of the beam. Now The bars are provided at top. The bars are provided at the top and the bars are provided at the bottom. So let me know how many bars are provided at the top and how many bars are provided at the bottom. Let me know the number of bars which are provided at top and at bottom and diameter of the bar. Okay, so it is 2 bars at top. 2 bars of what? 10 mm, 12 mm. And also tell me at bottom how number of bars and diameter of the bar. Both the things. Bottom 5 bars of 20 mm and at top 2 bars of diameter 10 mm. Okay. So at top now, here at the top, these are the 2 bars of 10 mm. Okay. And here these are 5 bars of 20 mm. Okay. I am not able to show all the 5 bars over here, so I have shown here 3 bars only, but you understand 5 bars are there. Okay. Now what is B1? Now B1 is the center to center distance. Okay. So the B1 is from this center of this bar to the center of next bar. Okay. So this distance is nothing but B1. So here from this point to this point. So this distance is nothing but here B1. Okay. Center to center of bar. And what is D1 now? So the D1 is from the center of this bar to the center of this bar. This is nothing but D1. This distance we can call it as a D1. Okay. So this is our D1. So now both the distances we need to calculate now. So what is the width of our section? What is the width? This total dimension. Width of our section is 300 mm. Okay. And what is the depth? What is the depth of our section? This total dimension. This depth. It is how much depth we have provided? I think we have revised the depth now. So what is the depth we have provided? 4 bars of 20 mm at bottom. Okay. So let me know the depth, overall depth of our section, that is our beam. What is the overall depth? 670 mm. Okay. This is our overall depth. So this depth is nothing but this is 670 mm. Now B1 is equal to. Now B1 is equal to. So B1, this total is 300 minus this cover, clear cover we have assumed 25 mm. So now right now I will go from this side. Okay, first I will come at the center here, from this end to the center. So from this end to the center, if I want to come at center, then from this much of the I should minus this much of distance. Okay, हे एवढं distance मला minus करावं लागेल. What that distance comprising of? So here I should consider the clear cover up to this point, and then this bar diameter. Okay, this bar is there. So this bar diameter and then half of bar diameter, which is at top. Okay. So now it is minus 25 minus 10. Okay, minus at top 2 bars of 10 mm, so 10 by 2. So now we have reached to this point. Okay, similarly from this side also, similarly from this side also, we should do the same calculation. Now from another side, if I consider, then it is again minus 25 minus 10 minus 10 by. So if you solve this, you will get the value of B1. So let me know the value of B1. What is the value? So the B1 is equal to, let me know the value. So the value of B1 it is 220 mm. 220 mm is the value of B1. After that we will calculate D1. So D1 is equal to, now this vertical distance we should consider. So right now I will start from this top point. Okay, from top we need to come at the center of this point, and from bottom also we need to come at center of this bar. Okay, so that thing we need to do. So from top, first of all, the overall depth is 670 minus clear cover is 25 minus, okay, minus, now this horizontal bar we should consider, diameter is 10 mm, bar of stirrup, minus from top it is 10 by 2, okay, minus. Similarly from bottom also we should consider the same. So from this point to this point there is clear cover of 25 mm. Then this bar of stirrup we need to minus, it is 10 mm, and then half of bar diameter of this bar. Okay, so 20 by 2. So now here again minus 25 minus 10 minus 20 by 2. Do the calculation and let me know the value of D1. And don't send me the answers on private chat. Send the answers to everyone so that everybody can cross verify the answer. So if some answer get wrong, we can correct it on time. Okay, at that moment only. So you share the answer in the chat to everyone. 585 is the answer. Okay. So 585 mm. So now we got the values of B1 and D1. Now we will proceed and we will use that formula which is given in the IS code on page number 75 to calculate the spacing. Okay. So now moving further, ASB is equal to formula is U into SB whole divided by B1 1.87 FY plus U into SB divided by 2.5 D1 to 0.87 FY. Now just put all the values over here, so we will get the answer. So ASB is equal to, what was the value of ASB? The value of ASB was 157.07. Okay. So this answer is in kilonewton or Newton? Okay, sorry, this is mm square. Sorry, TU we should put in Newton because this Fy value is in Newton per mm square. So what was the value of TU? Let me know the value of TU and VU. What was the value? TU and VU. VU I think 90 is given to you, no? 90 into 10 raised to 3 SB. If anything goes wrong, let me know right now at this time only. Please check the values. Okay. Then here B1 D1 0.87 FY. So values of B1 D1 220 and 585. So it is 220 into 585 into 0.87. This is the answer. Now plus VU is 90. Okay. So plus VU is 90 into 10 raised to 3 into SV whole divided by 2.5 into 585 into 0.87 into 415. Okay. So if we solve this, we will get the answer. 10 raised to 6. Okay, correct. Okay. So what is the answer now? Please do the calculation fast. Let me know the answer. 93.72. Okay. So the spacing is very less we are getting over here. 93.72. 93.72 mm. So we can round up this value to 90 mm center to center. Okay. So this is 90 mm center to center. Now we should check the class for minimum shear reinforcement also. Okay. So minimum spacing, that is ASV again. Okay. So now by using the same clause now, again ASB is equal to what is the formula? So it is tau VE minus tau C, tau VE minus tau C. Okay, so tau VE minus tau C, B into SV, B into SV whole divided by it is 0.87 F1. Okay. Now put the values over here. 157.07, which is equal to, here in the bracket, tau V was 2.47 minus tau C was 0.56 into B is 300 into SV is as it is whole divided by 0.87 into 415. Okay. Therefore, SV is equal to 98.97 mm. Okay, it is 98.97 mm, which we can round up to 95 mm center to center. Okay, so now this is the criteria which is given on page number 75. Now again, if we go to if we go to page number 48 in the IS code. Okay, so page number 48 in the IS code, then we will get the clause for the spacing that you already know. I have told you the clause. Okay. So on page number 48 here, so we need to use the clause that is x1 plus y1 by 4 and 300 mm. This clause here we need to use. Okay. So this clause we need to use to calculate the spacing. So now we will use this. So for that we need to calculate what is x1, what is y1, and then we have to use this. So we will go to the board. Okay. So now here x1 and y1 now. So again I will draw the diagram. So this is the stirrup, and now this is our beam section. Okay. And so the covers, So the distance is nothing. If we want to calculate this distance, then it is nothing but x1 is from the center of this. Okay, so if I draw the line like this, from the center of the stirrup, center to center of distance of the stirrup. So this distance is nothing but your x1. Okay. So this distance is nothing but it is x1. And now what is y1? Again, if we go for y1, okay, again from the center of this stirrup, that is the vertical distance from the center to again center. Vertical distance is nothing but y1. So this distance, which I am showing right now in the figure, so this distance is your y1. Okay. So this distance is y1. So now we need to calculate the x1 and y1, and we know that this total distance is 300 and this total distance is 670. Okay, so this total is 300 mm and this total is 670. So now for the further calculation now. So for the further calculation now, we can calculate x1 and y1. So x1 is equal to, so again now this total is 300 minus 25 minus half of bar diameter of stirrup, again minus from right side also 25 minus half of bar diameter of stirrup. So therefore x1 is equal to, let me know the value of x1. I'm waiting for your answer. Let me know the value of x1. x1 is 240. Okay, so the value of x1 is, it is 240 mm. Similarly, we will calculate the value of y1 also. So y1 is equal to, it is 670 minus 25 minus 10 by 2, again minus 25 minus 10 by 2. So if we solve, you will get the value of y1 also. x1 is 240, y1 is 610. Okay, y1 is 610. So this is the value of y1. Now calculate the spacing. Now we know the value of x1 and y1. Now calculate the spacing again. So next thing is spacing. Spacing SB is equal to, according to IS code, first it says that it must be equal to x1. So what is the value of x1? So x1 is 240. So it is 240 mm center to center. Then again spacing is equal to, spacing SB is equal to, it is x1 plus y1 by 4. x1 plus y1 whole divided by 4, which is equal to 240 plus 610 divided by 4. Let me know the answer. And in no case spacing SB is equal to 300 mm center to center. 212.5, 212.5. This answer is 212.5 mm, which we can round up to 210 mm center to center. Okay. Now see all the spacing and provide minimum spacing. Okay. So if we see here, three values are there: 240, 200 and 300. Out of these three, the least value is 210. Then if we go for first spacing, here the value is 95 mm and here the value is 90 mm. So least of that is 90 mm. So provide that. Okay. So we can write over here, provide provide two-legged 10 mm diameter stirrup about 90 mm center. So B1 now, see, you have to see the bars which we are providing it at the top and at the bottom. Okay. So the bars which is having the less bar diameter, at that portion you should take the value of B1 and accordingly at top or at bottom. Suppose now at top two bars of 10 mm diameter are there and at bottom two bars of 20 mm diameter are there. Then you should calculate B1 at top. Now there is one question where to consider the B1. Okay. So now if I draw the diagram over here. So now let us say this is our stirrup. And now I will draw the bars inside it. So here I will draw one bar, and here another bar is there. At top two bars are there, suppose now, and at bottom also two bars are there. Okay, and now I will draw the surrounding of this beam. So this is our section now. So now how to calculate the B1? At top, it should be calculated at top or it should be calculated at bottom. That is the question. So now what I want to tell you that here, suppose these bars are two bars of 10 mm. Okay. And suppose these bars are two bars of 20 mm. Now we will calculate the B1 at both. Okay. Suppose the clear cover is 25 mm. Okay. Clear cover is 25 mm. Just pay attention over here. Don't write anything from this. So now I want to calculate B1. So B1 is nothing but my B1 is the center to center distance of this. Okay, at top this is my center to center distance, and if I go at bottom then this is my center to center distance. Okay, for B1. So this is here it is B1, here also it is B1. Okay, just we are talking about B1 only. Okay, because there is no such a question for D1. So now we what to take. Now suppose if I calculate both the B1. Okay, suppose if I calculate both the B1, then what do I get? B1 at top now. Suppose B1 at top. What is the value of B1 at top? Then I should consider this. Whatever there at the top, I should consider this. Okay, suppose this is our B1 at top and this is our B1 at bottom. We will find out both the values and then I will tell you which is to take. So now if I calculate this now, suppose the diamond width is 300 minus clear cover is 25 minus then stirrup bar is 10 and then minus half of bar diameter, that is 10 by 2. Similar, this should be repeated from other side also. Okay, so here you will get the value of B1 from top, at top. Okay, now suppose now if I calculate the B1 at bottom. So what will be the formula, then what will be the change? Then it is 300 minus clear cover is 25 minus diameter of stirrup is 10 minus again now instead of 10 by 2, if these bars are 20 mm then it will be 20 by 2. Okay, minus 25 minus 10 and again minus 20 by 2. Now calculate both the values. Okay, first let me know what is the value of B1 at top and what is the value of B1 at bottom. B1 at top 220. Okay, so here at top we got the value 220. So this value is 220, and at bottom 210. Okay, so at the bottom this value is 210. So this value is 210. 210. Okay, so which is the maximum value now? The maximum value is 220, which is at top. So I can say that at top or at bottom, where the bar diameter is less, where the bar diameter is less, there you should calculate the value of B1. Okay. Here see your bar diameter is 10 mm. So for at the top we should consider the value of B1. Okay. Now suppose the bar diameters are equal at top and bottom, then you will get the same value over here. At top also, at bottom also. So although you are seeing that there is not much more difference, here it is 210 and here it is 220. Just 10 mm difference is there. Okay. So we will go for maximum value. Now in the problem, if you see, we calculate B1. No, in last problem we have not taken B1 at bottom, we have taken B1 at top. Last problem also. Okay, you might have calculated at bottom, then the answer may be wrong. You have to make the correction. B1, maybe the bars are same at top and bottom. No, at that case, I don't remember the last problem, but now whatever I am telling you, remember this thing. B1 should be calculated where the bar diameter is less, because we want the maximum value of B1. Okay, we want the maximum value of B1. So here if bar diameter is 20 mm now, your B1 value is going to be reduced. And if the bar diameter is 10 mm, your B1 value is increased. Okay. So now where the bar diameter is less, at that point you should calculate the value of B1. This is the thing. Okay, and I don't think so in the last problem we have taken the minimum value. Check it once again. I think we have correctly calculated the value, and if still the same problem is there, you can tell me after the lecture on WhatsApp, then we will take that part into the next lecture. Okay, for all the students. Okay, so roll number 53, you are saying that now we are taken in last problem B1 at bottom. So please check it once again. If this is the case, then we will revise that in the next lecture. Okay. So now this is the difference where you should take the B1 now. I hope you will clear with this now. Okay. So now next. So next thing is, so after the spacing 90 mm, we have provided the stirrups now. Okay. So provide two-legged 10 mm diameter stirrups about 90 mm center to center. Okay. And the final thing is we should draw the reinforcement details. So in the reinforcement details now, first of all, we will draw the stirrups. Okay. Then beyond that, our beam section. This is the beam section. Okay. So after this, bars. So at top two bars are there. So I have kept there two bars. At bottom, five bars are there. No, 1, 2, 3, 4, 5. Okay. So here I will write two bars of 10 mm diameter at top. At bottom, 5 bars of 20 mm diameter, and this is two leg 10 mm diameter stirrup about 90 mm center to center. Okay. Then the dimensions, this total dimension, this is 300, this total dimension depth, this total dimension, this is 670. So this is 300 mm and this is 670. So roll number 42, what do you want to say? Is there any
Sir.
problem?
No, sir.
Roll number 42, Pramod Kale. Is there any problem? Is there anything
No,
you
sir.
want to say?
No, sir.
So 670 mm here you should write 670 mm. So this is your diagram. Now we have solved this problem also. So in the next lecture, we will go for the next unit column, our unit number 7. That is the last unit. Till now, still time is there. So we will go for this, what we can say, next problem, and we will solve this problem, and the remaining part of the problem you take it as your homework. Next problem, take the next problem. The given problem, to determine the reinforcement required for rectangular beam if the width of section is 350 mm, depth of section is 500 mm, bending moment is 52 kN meter, twisting moment is 26 kN meter, shear force is 46 kN. Use M20 and Fe 415. Take span of beam as 6 meter. This problem, this is your homework problem. Okay, this is your homework problem. Solve this problem by yourself. Okay. So in this problem I want to tell you certain things. So here they have given only the bending moment. They have not told you that this is factored moment or this is ultimate moment. Okay. So if only bending moment word is there, then you need to multiply this value by 1.5. Make it as a ultimate or factored moment. Okay. Similarly, twisting moment, this is only the twisting moment is given. So again you need to multiply this 26 by 1.5. For shear force, 46 is given. So again you need to multiply the shear force by 1.5, and then you will get ultimate bending moment, ultimate twisting moment or torsional moment, or and shear force, that is ultimate shear force. Okay, and then you should solve your problem further. So to calculate ME1, then see whether ME2 is required or not. Okay, then take the check for depth, and accordingly you proceed further for the steel calculation. Okay, and after the steel calculation, calculate the value of tau VE, calculate the value of tau C, see whether the shear reinforcement is required or not, and accordingly do the further steps. Okay, so this is your homework problem, and with this our this unit is end over here. This is the only type of the problem which can be asked in the examination. There is no any other, what we can say, variety in this. Okay, only the thing is that sometimes we need to calculate ME2 also, that is the bending moment which is developed in opposite sense, and sometimes it doesn't need, it don't need to calculate the value of ME2. That is the thing only. So now drop your roll numbers into the chat box. Okay, so we will end over here.